In our last video, Lesson 7a, we learned about a data type called a dictionary, or a dict, in Python. In this lesson, 7b, we're going to learn about yet another useful data type in Python, and this one's called a set. So, what is a set in Python? Well, let's think back to what we think of a set as in math. In math, a set is a collection of items, and it has no specific guaranteed order, and no item can appear more than once. For example, the following all represent the exact same three-element mathematical set. Curly brace 1, 3, 5. That's a set containing the elements 1, 3, and 5. This one is a set containing the exact same three elements, so these are the same set. They don't look the same the way I typed it in, but they are the exact same set. And this one's the exact same set also. The set containing a 1, a 5, a 3, and a 1 is the exact same thing as the set containing a 1, a 3, and a 5. No duplicates. Now, in Python, what's the difference? Well, let's see. Python, a set is a collection of items that has no specific guaranteed order, and no item can appear more than once. That's identical to our mathematical definition. So, how do we create sets in Python? Well, here's a way to do it. I can do s equals, and then in these curly braces, put my set elements separated by commas. We used curly braces in our last lesson to do dicts, dictionaries, but each item separated by the commas was a key value pair. Here I'm just putting the values in. Python knows if I've just got values, not keys and values, make it a set, not a dictionary. So at the end of this statement, the variable s now is an object of type set containing 5 elements. One of the elements is the int 3, one is the int 5, one is the string bananas, one is the float 17.5, and one is the tuple that contains 3 values 0, 3, and 4. Here, t equals the curly braces, quote, bananas, the tuple 0, 3, 4, a 5, a 17.5, a 5, a 3, a 3, a 3, and a 3. The variable t is now also an object of type set that contains the exact same 5 elements as s does. T and s are the exact same set. Now, let's create a list. Square brackets, so it's a list. Curly brace means I'm either doing a dictionary or a set. But this square bracket means I'm doing a list that contains a 3, a 5, the string bananas, the 17.5, and this tuple. So L is a list. If I then do U equals set L, the variable U is now an object of type set containing 5 elements that were the 5 elements of the list. I can create an empty set by doing S equals set open and close parentheses with nothing in them. Note, I can't just use open brace, close brace to create an empty set, because that creates an empty dictionary. Since they're both surrounded by the curly braces, this has to be chosen to be either a set or a dictionary by Python when you type it. The default is dictionary. So if you want an empty set, you're always going to do set parenthesis. Now, how can you modify an existing set? There's a lot of things you can do that correspond with things you could do mathematically. You may never use some of these, or maybe you'll be writing programs where they'll be useful. Let me just show you what they are, and you can always find more information in the Python docs. The first one we'll use a lot. s.add x. It adds item x to set s. If it didn't already exist, it adds it. If it did already exist, it tries to add it, but since a set doesn't contain duplicates, it doesn't make any difference. Set.clear will remove all the items from set s. S.discard x removes item x from set s if it's in there. So if you want to discard a 3, it'll get rid of the 3. S.intersection with t returns a new set that has each item that's in both s and t. So the intersection of two sets. And you can use this notation. S ampersand t means the same thing. Return the new set that is the intersection of these two. S union t, or S with the vertical bar in t, return a new set that have all the items that are in either one, the union of the two sets. S.difference, or S minus T, returns a new set that has every item in S that's not also in T. Gives me the mathematical set difference. Now, how do we step through a set with a for loop? We saw an example of doing this with dictionaries in our last video. How can we do it here? Let's see. S is the set, same one we used before, 5 elements, a 3, a 5, a 17.5, the string bananas, and the tuple 0, 3, 4. When I do for x in S, print, and I'm putting a little bit of blank in the beginning, and then x, it's going to print those. Each time through this loop, it gives me one more value from the set, goes through the loop however many times we have elements in the set. But the order is not guaranteed. You want to guarantee order? Put them in a list. You don't want to guarantee order? You can use a set. So, I might get 17.5, then 3, then the tuple 0, 3, 4, then a 5, then the string bananas, or maybe I'll get bananas first, and then 17.5, and then 3, then the tuple, and then a 5. Or maybe the 5 will be first. You can't guarantee it, you can't predict it, but you can guarantee that this loop will go through every single element. So that's how you use a set. Here's an example of something that might be terribly useful. Suppose you had a list of data that contained lots of cities and temperatures. You know, maybe you had 30,000 records, and they all had city and temperature data, and there was a lot of cities, and all you wanted to know was how many cities are represented in here, and you don't want to print out 30,000 things and look through and see, wait, did Dallas show up in there? Was New Orleans in there? Was Boston in there? Was Philadelphia in there? So, suppose we had a set, or a list, we're going to call it L, and the list contained a bunch of lists. Boston 50 degrees, Dallas 80 degrees, Chicago 48.3 degrees, Boston again 42 degrees, Boston again 19, Dallas again 90, and so on. Suppose maybe I read this in from a file, and I've got lots and lots and lots and lots of elements of this list. L is really big. If I do cities equals this empty set with nothing in it, then for each element in L, do cities.add element 0. What are elements in L? They're things that look like this. A list of 2 items, city, temperature, city, temperature, city, temperature. So if I add element 0, I'm adding just the city. So I'm adding Boston, then I'm adding Dallas, then I'm adding Chicago, then I'm adding Boston again, but Python won't give me a duplicate. Then I'm adding Boston again, but Python won't give me a duplicate. When I'm done with this loop, I've got a set called cities that just has in it Boston, Dallas, Chicago, Los Angeles, and whatever other cities are in this list. And that's it. Each one shows up only once. Useful way to find out what are the unique elements in a list of data. Hint, this might be something you want to remember when you do your week 7 and 8 programming assignment.